Okay, data scientists, SPLs, welcome back to our week 6, lecture 2 of 4. Now I want to go over our previous assignments that I outlined that I would from our week 5. Now, as I mentioned, those two assignments were really, I like to think they was really solid. Even the discussion post where we actually go over the topic that I present to you guys, and then you guys give me a solid understanding of what I'm asking out of you on the topic that I think is best for the ensuing week. And it looks like you guys nailed it as always, and I appreciate that. But the part that I really like to really look at is your engagement with your peer responses that were due no later than last night at 11:59 on Sunday. So I've been looking at those this morning, by the way. So those are always interesting because I like to see the dialogue that you have with your peers because we're all in this together. And it's one thing to make sure that you have your initial discussion post already completed on by Thursday so you don't lose any points. But that engagement piece is huge, especially in regard to the topic that I presented to you guys, and then you show me that hey, Dr. Mark, he's really wanting to see what I can really bring on the topic. That's really current to our assignment, the book readings primarily for the week. So let's look at that, guys, because I want to think, like I said, that actual discussion post was all about nays, bays, and the therefore mentioned logistics, right? Logistics regression. So it's a carryover from week 4. As always, in regard to in this case, logistic regression, how it coincides with nays, bays. Okay. So if you guys understood naive bays, then you was good on the assignment. And like I said, it's an open discussion, so there was nothing to get discouraged about in regard to understanding my topic. And the discussion topic that I presented to my uh, data scientists, aka statistical uh, young geniuses, I like to think, okay, that when I stated that when we want to know the predicted probability that a case belongs to a certain class, well, not the certain piece, but I did say class, often we use the naive Bayes algorithm, as you guys found out, and logistics regression, right? Those two typically coincide whenever you want to know any type of predicted probability. And you read up on that in your book chapters that we'll talk about, especially section 8, 8, 1 through 4, and also the other material that I outlined previously in lecture 1 and 4. Okay. But there was two primary areas that I wanted you to show me that you understood the conveniences versus advantages, right? When you're talking about nays, bays over logistic regression approach. Okay, that methodology or approach, I want to see if you can list and explain two advantages, okay, versus conveniences of the nays bays over logistics regression. So that was huge. And I've read you guys' responses. And you guys, like I said, you nailed it, you understand it, you see how it actually there is a difference, right? It's not similar by no stretch of the imagination. So you had to really understand the advantages versus those conveniences, right? And explain at least two of them for each and really just articulate that so your peers can engage with you because each of you had different perspectives and that's the reason I want to see the overall differences within my peers, my data scientists, peers, you guys, uh, statistical minds. Show me how you actually look at naives, Bayes, and logistics regression versus a logistic regression approach. And you guys really articulated that very well. So again, good job with that. But then there was a second thing that I wanted you to talk about in our week 5 assignment. Okay, this is first assignment, but you had two areas that I wanted you to really differentiate and really break down for me in a granular manner. Okay. So the second area was where you had to listen and explain the disadvantages versus conveniences. The first one was the two advantages versus conveniences. Now there was two disadvantages versus inconveniences of the naive Bayes over the logistics regression approach. Okay. So, it was pretty much, it was alike, but it was different, right? So it was alike a little bit, but it was truly a big difference in exploring those two areas, as you guys saw from your initial discussion topic, okay, from last week, week 5, right? So once you got that all squared away, and my key thing was, and this was huge, guys, you guys know, make sure that we get your initial topic in by Thursday so you can get those easy 20 points in full for the most part, okay? As long as you don't really mess up what I'm asking for and don't give me what I need, then I have to take off additional points based on my directions and the rubric, okay? But I didn't see that thus far. Like I said, I haven't graded them yet. I just got all the assignments in late last night, and I went over a few um, last ones. Just wanted to make sure that you guys who submitted them late did actually get what I was talking about in regard to your peer responses and understanding what your peers are saying, and you're responding back in a scholarly manner. So I did see that not only late last night, but this morning as well. So good job with that, everyone, as I previously have commended you guys on. Okay. So these two responses, at least a minimum of two responses to coincide with these two areas that I want you to look at, were due late last night. So, and like I said, doing my sample checks, it looks good, guys. I'm really, really liking the way you guys think. You already had those statistical minds, it looks like. As data scientists, you guys understand how to differentiate data, how to really make sure that the data is not imbalanced and making the data usable, balanced per se, therefore cleansing the data, understanding what you're working with. And that's what it's all about, guys. Taking an approach, making sure you can use it to bring out the best in what you're looking at. You guys understand in regard to, say, for example, logistic regression. So you guys are getting it, and by a long shot. So really good job on this past discussion post, at least from what I can see from the outside looking in. Like I said, I haven't got into the weeds yet, but I will. And you know me, I will definitely give you kudos or really give you some guidance if it's not where it needs to be. Okay. But like I said, this is one where you can get an easy 20 points, and it's all about being on time and engaging with your peers. And if you do those two things along with giving me the right responses that I'm looking for. And it's all derived from the book. So if you follow the book, go to those areas, and now use the data that I'm giving you in regard to the data indexes, you'll be good to go. So, and that's what it's all about, guys. Just following directions, being on time, being professionals, being the leaders, SPLs, scholar practitioner leaders that you are, doing this assignment in that manner, in that SPL framework, you'll be just fine. And that's not only this assignment, that's all the things that I present to you. Show me that you are, in fact, leaders on the scholarly side, as well as being a practitioner, actually getting into the work and really breaking down, just practicing what it's all about in statistics from a data scientist perspective. And you guys are truly getting that. So good job with the first assignment from what I can see. Alrighty, so that was the first assignment. We only had two, and it was worth those 20 points, this discussion topic that I just articulated to you guys. So good job with that. And then we had a second assignment, which was worth 80. Woo! 80 points. So this was a good assignment, guys. And it looks like you guys really enjoyed it. and you even had that drills with an R uh, tutorial tutor. Well, it is a tutor, but tutorial just in case you had any issues on how to use the R tool for this assignment. Okay, and you had data sets that you can use for R drills for this tool. So I gave you everything that you needed to be successful for the second assignment, which was entitled Drills with an R on Generalized Linear Models. And that was due late last night. So that's what I was looking at. And I've been looking at it this morning as well. Like I said, I gave you the indexes of data sets you needed. It's all about following directions, as I mentioned last week on these drills with an R. Just because the title looks sort of scary, the assignment was really straightforward. So, and I gave you a good 80 points. I started to make it 100, but I wanted to round out this week to be an even 100. So that discussion post was 20 points, and then you had this assignment, which was worth 80 points. So that way you guys can easily come out of this week 5 with a solid 100 points to boost up your grading, because you guys know our course is all about points, points, points. So the more points you get, the more you can get that elusive grade of an A. That I'm hoping that's what you want. I'm sure you're not trying to pursue a average grade, right? You don't want to do that. But if that's the case, also because maybe you're working really hard, however, and smart, but your points just didn't add up to the A area. It would average up to an average area, which is typically a C. Okay, but I'm always for the high end, just like I know that you guys want as well, based on the feedback initially that I've received from you guys. Okay, alrighty. So, but anywho, this actual drills with an R on generalized linear models was all about, as I mentioned last week, four houses data. It was all the data that I said. You had to go to that houses for data index inside the get that data set out of there from the index of data sets. Okay, and on the housing data, you had to consider Y equals selling price, X1 equals tax bill in dollars, as I mentioned last week, and then X2 was whether the house is new. And then there was two areas initially that I wanted you to look at. The first two areas was you had to form that scatter plot. So I've been looking at you guys' scatter plots for Y and X1. Kudos, kudos, kudos. And that's what I've been looking at this morning. Are these guys actually giving me my plots, my SPLs, my data scientists? Are you giving them to me? And yes, yes, yes. So I've been seeing that, guys. And then I wanted to make sure that the actual answer does the normal GL structure of constant variability, as I mentioned last week, in the Y seem actually appropriate? If not, how does it seem to be violated? So then you have to articulate that. Then second thing that I wanted, the first two areas, using the identity link function fit the normal GLM and then the gamma GLM, as I spoke on last week, for each model, and then you had to interpret the effects of the therefore mentioned X2. Okay, so those were the first two areas of this second assignment, drills with an R on generalized linear models. And then the third area, because it was a total of four, on the third area, I wanted you to tell me for each model, as I mentioned last week, you had to actually describe the estimated variability in selling prices varies as the mean selling price varies from 1,000 to $500,000. Okay, so you had to actually describe that to me and break it down in its granular essence and tell me how it varies and why is it varying as the mean selling price varies from 100,000, to that therefore mentioned 500,000. And then the last thing I wanted to see, guys, which is really straightforward, it was all about telling me which model is preferred according to the AIC. Okay. And you guys know what AIC is now because you read up on it in the book, which is huge. Okay, so all you had to do was tell me that, and that was it. The assignment was done. And then you had the data sets that you needed. I gave you the link there, the index of data. So useful functions in R to solve the problems for the assignment. So you had to read the table, the head, the GLM, and the overall summary. So that was it for our assignment 2. When I come back, guys, we're now going to do a deep dive into our current week 6 for lecture 3 or 4. See you in a second. Bye bye.